Good afternoon, welcome all. Am I audible? Hello? Am I audible to all of you?
Yes, sir.
Yes, sir.
Okay, fine, let us start. Before starting topic itself, as I came to know that all of you have received your fifth SEM results and hope all of you are doing quite well. Though I am much concerned about only the statistics paper, and as I came to know from different sources that uh, in statistics all of you are doing quite well. Fine enough. Let us start where we kept it hanging. The next type of method which we were talking about was moving average method. Before of this, we have seen two methods. One was freehand graphical method, or you can say freehand method or a graphical method. Any one of these two names can be used of. The second was semi-average, and in semi-average there were two different parts. One was if odd number of years are given and if the even number of years are given, there was some technical or you can say a practical approach to be used of. Now, shifting it to the next method, which is named as moving average method. This is a method which is used much in practice. Most of the time, you can say that this is highest used method among all of them. Again, in this method, moving averages are calculated on the basis of, again, a number is given to you. You have to calculate 3-year moving average, 4-year moving average, 5-year moving average, 7-year moving average, any one of these four types. What I am talking right now about is in your syllabus. In your syllabus, these are the four different type of moving averages we are likely to calculate. It can be 3-yearly moving average, 4-yearly, 5-yearly, or 7-yearly. Just try to focus on the number of years given to you 3, 4, 5, or 7. Look, 3, 4, 5, 7 are not the number of data set as it was in a semi average method. This is 3-yearly moving average, 4-yearly moving average, 5-yearly moving average, and 7-year moving average. This is what we are likely to calculate. Okay, to get it calculated, look, again we have made two separations in it. Because 3, 4, 5, and 7, among these four numbers, 3, 5, and 7 are odd numbers, whereas 4 is an even number. And there would be a little change in calculation if odd period of moving average is to be found and even number of moving averages are to be found of. So we have made a classification that if odd period of moving average is to be found, how one can calculate it and how it is to be proceeded. Right? Let us see one by one. We'll see it 3-yearly, then after we'll see it 5 years, 7 year, and ultimately even period moving average, which is a 4-year moving average. What I'm talking about right now is in your syllabus area. This can be much more even. It can be 3, 5, 7, 9, 11, or any number of moving averages are there. But in our syllabus, it is 3, 5, 7 as odd period and 4-year, which is as even period of moving average. Right enough? Now we'll be directly observing some of the examples. There are a few steps to be done of. Let us see. Odd period moving average. There are steps to be followed. Look, this is a theoretical part as such, but you will understand it better only if you make an example or you try to solve the example. What is to be done? Let us suppose a data set is given to you which is of 10 years. Naturally 10 years and a variable which is moving in terms of time. It can be sales, it can be profit, it can be national income, whatever it is, right? So one of the variable is time and another variable is a variable which is dependent on time. First of all, what we are likely to do is try to focus on first 3 years data. Once you fix up, first of all, concentrate on first 3-year data. Make a sum of it. And you have to put it in middle of those 3 years. Naturally, first year, second year, and third year, the middle year would be second year. So you have to calculate the sum of 3 years and you have to put it against the second year. Once you make a sum, then now skip the first year. So naturally the second element would be sum of second year, third year, and fourth year. Again you have to make a sum and you should put it in between. Naturally in between it comes to third year. Once you make total of each of them, then make another column named as average. Since it is a sum of 3 years, divide it with 3, what you will get would be the 3-year data divided by 3 means an average. So it would be 3 yearly moving average. That is what you can calculate it. That is how you can calculate it. The same process is to be done for 5, same process is to be done for 7. But this is a slide which describes it theoretically, so I understand that you may not get it clearly what exactly we are likely to do. Let us have one of the example, and as I suggested, since we are likely to have some of the example, I asked all of you to bring pen, paper, and calculator with you. So you can simultaneously calculate it and get it clear by simply doing it instead of by simply observing it. Right? Let us have example. Look, the example would be somewhat of this kind. From the following data, calculate trend values using 3 yearly moving average. Look, this is how it can be asked in examination even. So this number, whether it is a 3 yearly moving average, 5 yearly, 7 yearly, or 4 yearly, it will be given to you by examiner or in example itself, and a data set will be given to you. So first of all, in whatever way this data is given to you, put it in a column format. Make a table. The first column would be year, and the second column would be production. Come on, do it. I want you to do it simultaneously. So that will make it very clear to you what exactly you are likely to do. First of all, draw the first column, write an year as a title, and put all the years accordingly. Look, in this case, years are starting from 2001 with a difference of 1. Means 2001, 2002, 2003, 4, 5, 6, and 7. Put it in a column format like this. And put the production against respective year. In 2001, production is 412. Here it is 438, 446, 454, 470, 483, and 490. Put it in the second column. Once you put these two columns, you haven't done anything yet. We have simply represented the data in a different form. Here it was row-wise. Here you have calculated it, or you have represented it in a column format. The third column is required. In a third column, write a title as 3 yearly moving total. Since it is the first example, we will always write these totals and then after we will find averages. So first of all, make another column titled as 3 yearly moving totals. What exactly you are likely to do? In this case, as I suggested it earlier, that first of all, look, the first 2001 production is 412. In 2002, production is 438. In 2003, production is 446. These are the first three elements. Okay. In this first three elements, those three elements are to be summed up. So 412 plus 438 plus 446, total is 1296. Where you have to place it? You have to place it among these 3 years, whatever is the middle year, means 412, 438 and 446. The corresponding years are 2001, 2002 and 2003. A middle year among this first three entity becomes 2002. So you have to write it against 2002. Naturally, nothing will come in the first. So put a dash there. In the first entity, always there would be a dash while calculating 3 yearly moving average. Right? 412, 438 plus 446 becomes 1296, which is a 3 yearly moving total for the first 3 years. Once you do it, then skip the first year. Now, first year is not to be considered of, think of second, third and fourth year. That means 2002, 2003 and 2004. So the entity becomes 438, 446 and 454. So here it is 438, 446 and 444. Sum becomes 1338. Where it is to be placed? Exactly in between of the middle year among the 3 years, 2002, 2003 and 2004. Middle year becomes 2003. So naturally it should come against 2003. So 438, 446, 454 becomes 1338 and it is to be written against 2003. What should be the next step? Now skip first 2 years. So 2001 and 2002 are to be skipped off and now it is 2003, 2004, 2005. These 3 years are to be taken care of. In between, what is the middle year of all these 3 years becomes 2004. So you have to write against 2004. What is to be written off? Whatever the entity between of 2003, 4 and 5 are, which is 446, 454 and 470. Write it down against 2004 and that total becomes 1370. Right enough? Okay, what should be the next one? Now skip first 3 years. So now the year becomes 2004, 2005, 2006. Entities are 454, 470 and 483. Total is 1407. It is to be written in the middle year. For 2004, 2005 and 2006, middle year is 2005. So it is to be written somewhere here. Sorry. Similarly, proceed. Now skip first 4 years. So naturally the next level would be 2005, 2006 and 2007. Among these 3 years, middle year is 2006. So you have to write it against 2006. What is to be written off? 470, 483 and 490. Sum of these three, it is to be written against 2006. The total is 1443. Naturally, this becomes the last one because we don't have anything next to 2007. So there you cannot make a bunch of 3 years. So naturally at that point of time, here it comes as a dash. So one thing which you can observe from this example is wherever there is a 3 yearly moving average, the first entity would be dash and the last entity would be dash for sure. All other entities will be written as making a bunch of 3 and making a total of it. Again, this is total, it is not average. Now make another column of 3 yearly moving average, and it is called trend values. 3 yearly moving average. 3 yearly moving average is a word used to be used as method, but by this method what you are getting is a trend value. So it would be 3 yearly moving average trend values. That is what it should be the title of fourth column. Now whatever written in the third column is divided with 3. Dash divided by 3 remains dash. 1296 divided by 3. As it is a 3 yearly moving average, we have to divide it with 3, so it comes to 432. Similarly, 1338 divided by 3, it comes to 446. 1370 divided by 3, which comes to somewhere 457. We have rounded it off. 1407 divided by 3 becomes somewhere 469. 470, 483, 490, 1443 divided by 3 becomes 481. So look, again in the 3 yearly moving average trend values, first and the last remains dash, and you will get all the values in between of those years. And these values are known as 3 yearly moving average trend values. Is there any problem? Is there any difficulty in understanding in this method?
No, sir. No, sir.
It is very simple. Make a bunch of 3. You have to put some. Initially, you have to put a sum, and then after you have to put an average in the middle year. It is as simple as that. So this is how 3 yearly moving average trend values are to be found out. Absolutely clear?
Yes, sir.
Fine.
Yes, sir.
Let us see the next example. From the following data, calculate 3 yearly, 5 yearly, and 7 yearly moving averages and plot the data on the graph. Years and cyclical fluctuations are given to you. Okay. Would you be able to do it?
Yes,
What
sir.
are the differences? Try it. Up to 3 yearly moving average, I don't think there would be any issue for you. In a 5 year, a bunch of 5 is to be made. In a 7 year, a bunch of 7 is to be made. That is the only difference. So first of all, think of 3 yearly moving averages. That would be simpler for you, as you have seen one of the examples before this example. As I said it earlier, make 2 different columns. First column should consist year. Year starts from 1989, 1990, 91, and so on up to 2003. The second column would be cyclical fluctuations. +2, +1, 0, -1, -2, -1, and keep on repeating the same 5 elements. 2, 1, 0, -2, -1. While putting it in a similar pattern, now, since the example which we have seen previous of this example was the first example. So we tried to make 2 different columns. The first column was 3 yearly moving total, and then we have divided it with 3, and then we got 3 yearly moving averages trend values, right? Here, once you have a practice of solving it, you will be able to put directly 3 yearly moving averages. Look, what happens in this case? 1989, 1990, 1991. These are the first 3 years. Okay. By considering this first 3 years, the middle year would be 1990. Fine enough. Here you have to make a bunch of first three cyclical fluctuation, which is +2, +1 and 0. +2, +1, +0 becomes 3. Since it is 3-yearly moving average, you should divide it with 3. Once you divide it with 3, it comes to 1. That 1 is to be written against 1990, which is directly a 3-year moving average. So instead of making two different columns, one of 3-yearly moving total and then after 3-yearly moving average, you can calculate 3-yearly moving averages directly. So 1 comes against 1990. Fine enough. What should be the second entity? As I said earlier that now you have to skip the first year. The first year is 1989 and that part is to be skipped. So next 3 years are 1990, 91 and 92. In among these 3 years, the middle year is 1991. Fine enough. You have to put some value against 1991. Now what you are likely to put? Naturally, +1, 0 and -2. Since it is +1, 0 and -2, the total is -1. Okay. Since the total is -1, since it is a 3-yearly moving average, you have to divide it with 3. That comes to 0.33, that too a negative. So minus of 0.33 should come against 1991. Clear?
Yes, sir.
Okay. Now skip first 2 years, 1989 and 1990. Now you have to bunch a 3-year as 1991, 92 and 93. 91 is 0, 92 is -2, 93 is -1. So making a sum of these three, it becomes -3. -3 divided by 3 becomes -1. So you have to put it against 1992 as -1. Similarly, proceed it for all the years. So what you will be having would be +1, -0.33, -1, -0.33, 0.67, 1, 0.33, -1, -0.33, +0.67, 1, -0.33 and -1. And again, since it is a 3-yearly moving average, the first entity would be dash and the last entity would again be dash. Right? Do it. Calculate it and verify it. Is it the right one? Are you getting the same amount? Do it right now. If anyone finds it difficult or a query, you can ask. And once you complete it, let me know. We'll shift to the next 5-yearly moving average.
Done for all three averages.
Okay. In 5-yearly moving average and 7-yearly moving average, the only difference is in 3-yearly moving average, you are making a bunch of 3, whereas in 5-yearly moving average, you have to make a bunch of 5, and for 7-yearly moving average, you have to make a bunch of 7. So one thing you can verify it, in the 3-yearly moving average, always you will get first year and the last year as dash. If you are having 5-yearly moving average, then you will have dash for the first 2 years and last 2 years. And for the 7-yearly moving average, you will have first 3-year dash and last 3 year, again you will get it as a dash. From which you can have an idea how they will be deciding this to use a 3-yearly, 5-yearly or 7-yearly. On which ground you decide that you have to calculate a 3-yearly, 5-yearly or 7-yearly moving average. You don't have to much bother about it as it is given to you, but think it as a statistician that if it is not given to you, how you will be calculating which yearly moving average is to be found of. Look, this dash gives, it has a role to play. If number of years are large, the data set given to you are large data, then 7-yearly does have some sense. It is just because of whatever data set is given to you, if you are calculating 7-yearly moving average, first 3 dots and last 3 dots means 6 data set is wiped off. So naturally, in that case, data loss is of 6 different elements. So if the number of years are large, then only it is, you can say, fruitful to get a loss of 6 years. Let us suppose data set given is of only 7 years and you have to calculate 7-yearly moving average, you will have a single entity. In that case, it doesn't make any sense to you. So if the data set given to you are in a larger number of years are given to you, then only 7-yearly moving average is better to found out. Same is the case with 5, same is the case with 3. When the data set given to you are small in the sense number of years given to you are not in a large number, at that time it is advisable to use 3-yearly moving average instead of 5 or 7. Though, again I am repeating it, though it is not your concern right now, it is just because of this 3, 5, 7 or 4, it will be given to you in the data set itself, in the question itself. But you should understand it. Data speaks. Once you observe the data, data will speak by all means. I hope all of you have done this 3-yearly and then after 5-yearly and 7-yearly. Have you, if you do it, there is a, you can say, a factor of surprise even. Does anything surprised you? While calculating this 3-yearly, 5-yearly and 7-yearly moving averages, have you found anything which is little surprising for you?
In 5-year data, all answers are 0.
In the 5-yearly moving averages, each of them you are getting as 0. Have you thought of why it is happening so?
As the numbers are positive and negatives.
Okay.
Fluctuations are positive and negative.
fluctuations are positive and negative. Yes, Payal?
At every 6th year, the value is 0.
Every 6th year value is 0. 1, 2, 3, 4.
Like in 1991, it was 0, and then in 1996, it is 0. Then in 2001, it's 0.
So that made 5-yearly moving average 0. Is it so? That is what you want to say?
Yes, yes.
Okay. Anything else?
No, that's it.
Is there anything other point which you are observing? Why this 5-yearly moving average, all of them are 0? What made it 0? Just observe it. You should have an observation skill, and if you have a good observation skill, then you will come to know many things earlier than anyone else. Yes, Payal.
Each number is -2 and includes 2, 1, 1, 2 and 0 only.
Right. For a moment, if I make a little change in this data, +2, +1, -2, -1, and then after 0, then it will be 0, +1, +2, -2, -1. Means I am just trying to dislocating the cyclical fluctuation. Values will, as you said, it is just because of value you are getting it, right? Okay. Since these values are given, and if I am dislocating all these values, then you will have all the zeros again. Let me put it other way out. Number of +2. 1, 2, 3. 3 times it is +2. 3 times it is +1. 3 times it is 0. 3 times it is -2. 3 times it is -1, right? In a data set, if I make a relocating everything, then you will have the same result in a 5-yearly moving average. 5.
Yes, we can get 0. If we relocate the data in a way like in 1989, the value will be -2, in 1990 -1, then 1991 0, then 1992 +2, 1993 +1, then we can get 0.
Okay. You are trying to dislocate it in frame. Try to understand it. In the frame in the sense. Why it is happening
Yes,
so?
yes.
Focus on it. Look, it is in a form of +2, +1, 0, -2, -1. Make a bunch of 5 now. Look, while making a bunch of 5, +2 gets eliminated with -2, +1 gets eliminated with -1, and ultimately 0, right? Means all the things, while making a bunch of 5, what you will get would be 0. 0 divided by 5, again it comes to 0. Clear? Okay.
Yes, sir.
Now, think of it, data remains same, and if you dislocate it in a different way in the sense, instead of 5 years, as I said it, +2, there are 3 entities. So let me put it this way, +2, +2, +2. This would be the first 3 element. Then after it would be +1, +1. Then after it would be +1, 0, 0, 0, and so on. Look, data remains same. But even though you will not have 5-yearly moving average as 0 in that case, so there is some pattern. Since there is some pattern, I want you to observe that pattern. Look, repetition is there among every 5 years. Look, +2, +1, 0, -2, -1. Now this set of 5 is repeating again. +2, +1, 0, -2, -1. Again the same pattern is there. +2, +1, 0, -2, -1. In short, data is grouped in 5 years, and that pattern remains same everywhere. And since that pattern remains same everywhere, you will always have 5 yearly moving averages as 0. If plus and minus entities goes off. Right? Yes, Payal.
Sir, if the data is like +3, +2, +1, 0, -2, -1, sorry, +3, +2, +1, then 0, -3, -2, and -1. Then we will get 7 yearly
7
moving
yearly
averages.
moving average is 0. It is as simple as that. But this is what I want. You should have that observation power, that how it is, why it is happening, how is okay. You will learn how it is to be done in a classroom. That is fine. Try to focus on why it is happening. There is a difference between how and why. Think of why it is happening, so that will give you a clear-cut idea. Okay, to make 3 yearly moving average 0, what should be the change to be done in this example? Come on. Payal, you have rightly observed that if it is +3, +2, +1, 0, 1, 2, and 3, in that case, 7 yearly moving average, all the entities will be 0. My question is, if I want to make 3 yearly moving average, all the entities 0, what should be the change? Yes, Payal.
The data should be in the form like minus +2, 0, -2, or +1, 0, -1.
Absolutely correct. It should be in a +1, 0, -1, or it is +2, 0, -2. In short, you have to make a bunch of 3, and that should repeat throughout. So you will get 3 yearly moving average as 0. It is as simple as that. With this 2 example, you learned to calculate 3 yearly moving average, 5 yearly moving average, and 7 yearly moving averages. Here there was one more thing, that plot this data on graph paper. Plot this data on graph paper. If this is given to you, now you have to plot these points on a graph paper. Okay, let us suppose a 3 yearly moving average graph paper, naturally all the years 1989 to 2003, of which 1989 and 2003 are not there, so 1990 to 2002. That data is to be plotted. So the first entity would be, coordinates would be 1990, and 3 yearly moving average is +1. Right enough? Okay, now let us see. I have tried to put all the data, which 3 yearly, 5 yearly, and 7 yearly, on a same graph paper to make it understand well. So you can observe the difference between this 3 yearly, 5 yearly, and 7 yearly. And the actual is always there. This is how this graph may look. First is actual value. It starts with 1989. Entities are from -2 to 2, so you have to keep it in a form of, I have take it as this way, -2, -1, 0, 1, 2. This is the difference of 1. I have plotted, first of all, actual points are to be plotted. Then after, plot 3 yearly moving average with a different style. It is a dash line, an average dash line, which is 3 yearly. Look, 5 yearly. 5 yearly, all of them were 0. So at that point of time, line would be parallel to x-axis. Similarly, 7 yearly with a little broad dash. With a little broad dash means this is 7 yearly. You have to write it down. This is 7 yearly, this is 5 yearly, this is 3 yearly, and this is actual. Right? So from this you will be able to get the trend in a graphical form. Generally, by calculating 3, 5, or 7 year all together, you will see it how things are displayed in a graph paper. Is it clear now?
Yes, sir.
Can we shift to the next part of it?
Yes.
Yes, sir.
Fine. The next one. Now, 3, 5, 7. All these odd numbers are done. What will happen when a 4-yearly moving average is to be calculated? Then there are two different methods to get it done. Though these two methods are not exactly the two different methods, but in this case we have to do things differently. That is all. In the first method and in the second method, we will directly observe it by taking example. Instead of describing it theoretically, once you have an example, that will make the whole thing clear, absolutely clear, right? Now, our intention is to get 4-yearly moving average. Can anyone say what would be the hitch in this 4-yearly moving average? What can be the hitch? Whenever it should come in your mind, I want you to think of it. Once you think of it, it will be very clear to you. When you are using a 4-yearly moving average, so naturally you have to make a bunch of 4, and while making a bunch of 4, you have to make a sum of it, you have to divide it with 4, fine enough, and you have to put it against the middle year. When 4 years are given to you, which one of them would be middle year now? Let us suppose 1990, 91, 92 and 93. These 4 years are given to you with some data set, right? Okay. Once you make a bunch of this 4 year, you have to put a sum of all those 4 entities exactly in between of this 4 year. Where exactly it will come?
Second and third.
Second and third. So naturally it would be somewhere in between of second and third. Okay, while putting it between second and third, naturally, this is not a right way. I mean, there should be some other way out. Okay, then what should be done?
And
Do the
after
same.
we have to add those averages again and divide by 2.
Absolutely correct. You have to make averages 2 times. So first of all, make a bunch of 4, make a total. There are 2 ways. This first and second method means this total is to be averaged. First of all, make a sum of 4 element, put it against the middle year, which is, as you rightly said, it should be in between of, naturally it would be second and third element. Each of the element would be in between of certain years. Then again do the same process, now taking 2 elements simultaneously, the first element and second element, make an average of it, put it against, so that will give you the entity which is against some number of year, and then after you can make an average. Let us have an example that will make it clear instead of this hypothetical way. If one example is given to you, the things will be very easy to you. We are focusing on the first method of it. Let us see. Look, this data set is given to you. Calculate the trend value using 4-yearly moving average from the following data. Data set is given to you, consists of 2001, 2002, 3, 4 and so on up to this time. So 2001 to 2010, that should be the first year column. The first column should be 2001, 2002 and so on up to 2010. Since there was I was not having a liberty of getting all the data on the same slide, so it is in a 2 different slide. 2000 to 2005, which is in this slide, and onwards it is in the second slide. Fine enough. Okay. One thing all of you are likely to consider of, and you have to keep it in mind, that while using 4-yearly moving average, always put a line in between of each of the year. While writing first column as year, just put a blank line in between of each of the year. 2001, a blank line. 2002, blank line. 2003, a blank line. 2004, a blank line, and so on. Proceed it in a similar manner up to 2010. Fine enough? Because that middle year is somewhere used. Okay. As I said, it 4-yearly moving average. The first thing is to be done is make a bunch of 4. So first 4 elements, 7, 8, 9 and 11. These 4 elements are there. Among these 4 elements, you have to make a sum. So it would be 7 plus 8 plus 9 plus 11. So total comes to 35. Where you have to keep it, where you have to put it, it should be in between of 2002 and 2003. So naturally, if you put a blank line here, then you have to put it against 35 against this value. So it would be 4-yearly moving total. Right enough? First element is clear?
Yes, sir.
Okay. Do the same by skipping the first year. Now 2001 is to be skipped. Now again make a bunch of 4 years. 2002, 2003, 2004 and 2005. Okay. 2002, 3, 4 and 5, that means 8, 9, 11 and 10. The sum total is 38. Where you have to write it? Against 2000, in between of 2003 and 2004. So naturally this entity may come somewhere here. Similarly do for the next 4 years, similarly do for the next years, and similarly up to 2010. Do it right now. In this case, always title your column as 4-yearly moving total. Once you complete it, let me know. So the first element would be 7, 8, 9 and 11 in between of 2002 and 2003. Then it would be sum of 8, 9, 11 and 10. It should be between 2003 and 4. 9, 11, 10 and 12. It should be between 2004 and 5 and onwards similarly. What are the sum you are getting? Four-yearly moving total, the first 2 they would be dash, last 2 would be dash, against 2000, in between of 2002 and 2003 it would be 35, in between of 2003 and 2004 it would be 38, between 2004 and 2005 the sum would be 42, 2005 and 2006 in between sum is 41. What is the sum between 2006 and 7? What are the next sums? Can I get numbers?
36.
36 is the
36.
next. What is next?
Yes, 36.
36 between 2006 and 7. What is the number between 2007 and 2008?
31.
31. Right enough. What is the number between 2008 and 2009?
29.
Which is 29. Fine enough. Now you have all the sums with you. 35, 38, 42, 41, 36, 31 and 29. First two dash and last two dash. Fine enough? Okay. Now here, naturally, you have to process it once again. So 2-period moving total of 4-yearly moving total. Now again you have to make a bunch of 2. Look, first of all you made a bunch of 4 and now you are making bunch of 2 again. Bunch of 2 and you have to write it in between. So 35 and 38, make sum of this two. 35 plus 38, which comes to 73, and that 73 is to be rewritten in between of these two, which is against 2003. Good enough? So now this is called centering process, or you can say it is centered. 2-period moving totals of 4-yearly moving total. Instead of writing this much, you can write it that centered 4-yearly moving totals. અથવા 4-yearly centered moving total. That can be the title. It is fine. As they are not averages right now, they are totals. So while putting it in the next column, what are the numbers now? 73 against 2003. What would be the element against 2004? It would be 38 plus 42 becomes 80. A number which is against 2005 would be 42 plus 41 becomes 83. What would be the element against 2006 now?
77.
77, right? What should be the element against 2007 now? We are
69.
running out of time. Just try to make it little hurry. What should be? It is 67. What should be the entity against 2008?
It
is 60, 60. So all the values are 73, 80, 83, 77, 67 and 60. 2 dash at the upper end and 2 dash at the lower end. Fine enough? Now make a column, and that column is named as 4-yearly centered moving average. Now we are talking about average. To get this average, you should divide it with what should be the denominator in this case? That denominator should be 8. Why 8? Because first of all you made a bunch of 4. So there you have to divide it with 4. And then you made a bunch of 2. So again you have to divide it with 2. So in a division it is 4 multiplied by 2 becomes 8. So this 73 is to be divided by 8 now. 73 divided by 8 becomes 9.125 and it should be against 2003. Similarly, 80 divided by 8 becomes 10. 83 divided by 8 becomes 10.375. Next is 77 divided by 8 becomes 9.625. 67 divided by 8 becomes 8.375. And 60 divided by 8 becomes 7.5, which is against 2008. Somewhat like this. Right? Now here my intention was to make it clear that you have to divide it with 8. Why it is so? It is just because of you made a sum of 4 and then after again you made a sum of 2. So to get average at a first point you should divide it with 4, in the second point you should divide it with 2. So in the denominator it would be divided by 4 divided by 2. Naturally it is 4 multiplied by 2. So ultimately to get an average you have to divide it with 8. Then only you will get a 4-yearly centered moving average. Is it clear?
Yes, sir.
This was the first method. In a second method, the process is very simple. In a second method, what they do is you directly calculate average instead of making a sum. Instead of first column as sum total, put a average directly. Make a bunch of average and divide it with 2. That will give you directly a 4-yearly centered moving average. So the process is directly dividing it by 8. You can do it in a 2 different level. One is divided by, here what we have focused on is a total. And ultimately we are getting an average. In a second method, we are directly focusing on average and then after we will be directly getting a 4-yearly centered moving average. The only method to this first method and second method, the difference is process. Focusing on total, at that time divide it with 8. Focusing on average, you have to ultimately divide it with 2. That's it. Right? I hope this part is very much clear to you. In the next lecture, we will see the second method of it. Here we have focused on total and next time we will focus on average in the same example. So you will get it clear very much. Is there any problem within this now?
No, sir.
I hope things are easy. And you should have to practice it. Then only things will be little easier for you. As there are some limitations with this online teaching that I cannot see it whether you are doing it or not. That is why I asked all of you to bring paper, pen and calculator with you. Try to do it during the lecture. That will make you more clear. Right? Let us stop now. We'll see the next method in the next lecture. Thank you. Thank you for your time.
Thank you, sir.
Thank you, sir.